Okay, this is IM1 and we're doing lesson 5-3. We're talking about the difference between linear and exponential graphs or functions. All right, so by now you should know that a linear function is going to be a line. If I was going to draw it, it would look like this, right? It just has an upward trajectory, maybe it has a downward trajectory, right? If I was going to draw it as a function, we would have y equals mx plus b, where m and b are both numbers. Right? There's no exponents on the x, and the x is just in line with everything else. It is not an exponent itself. All right, and we can see that when we look at a table, right? So let's pretend that we're looking at a table where you're looking at how much you get paid every week. All right, so we're looking at your bank account. So let's say you get paid $10 a week. Okay, and you are really cheap because we're in a pandemic and you don't spend any money. So you have X and Y, and this is our weeks, and this is our money. Okay, so on the first week, you got $10. On the next week, your bank account, this is the money in the bank. In the next week, you add $10 to it, so you have $20. The next week, you got paid another $20, another $10, so you have $30. The next week after that, you have $40. And this keeps going, right? I could make a rule about it, and I could just keep going, extending it out. When you look at it, what you see is that in the dependent variable, the dependent portion, we have a plus 10, plus 10, plus 10, plus 10, plus 10, right? You know this. This is linear. You know this. So let's talk about exponential, right? So we've been talking about exponential this time. So exponential is going to look something like, it's going to have a curve that goes up like this, right? Or maybe it's going to have a curve that comes down like that. I'm going to abbreviate exponential so I don't waste your time watching me try to spell that. All right, and we're going to say, let's say that you have a lily pad, right? You have a pond with a lily pad. Here's your pond, and you have a lily pad that doubles every day. This is a pretty classic example, right? So it doubles every day. So on the first day, so this is our days, and this is our lily pads. So on day 1, there's 1. On day 2, it doubles. There's 2. On day 3, it doubles again. 2 times 2 is 4. On day 4, it doubles again. 4 times 4 is 16. Each one of them doubles. On the next one, it doubles. So 4 plus 4. This is 8. It doubles again. That's 16, right? 8 plus 8. We double again. 6. We're going to get to 32. And you start to see how this goes. And what's important here is while I could add 4 plus 4 to get there, what I am doing is I'm timesing it by 2. Every time I'm timesing it by 2. Times 2. Times 2. Times 2. However many times. If we wrote out what that would look like, we would have y equals 2 to the x, right? It's timesing it by 2. So in a table, the dependent is multiplied. And sometimes you have to follow it out long enough, because right here you could have said, well, it's 1 plus 1, but plus 1 doesn't work for the next one. So this is how you identify the difference between linear and exponential. When it's linear, again, I'll remind you, each of those is added. When it's exponential, each of those is multiplied.